Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 3, Lesson 12, Session 1, multiplying and dividing with negative numbers. So the learning targets include multiplying and dividing with positive and negative numbers. Write a negative rational number as a fraction in different forms. Use multiplication and division of rational numbers to model real-world problems. So let's take a look. So the Burj Khalifa building in the United Arab Emirates, UAE, is the tallest building in the world. It is 2,717 feet tall. Wow. Um, that's like a half a mile and has 163 floors. What is the tallest building you've ever been in? Let's see. I think the tallest building I was in was the Willis Tower in Chicago. And let me see, Willis Tower. So here it is. This is the Willis Tower, and there's an observation deck that's all glass. I've been on that. So you go out there and it's glass underneath your feet. You look down and there's the floor before you or the ground below you. That's what it looks like from outside. Okay. And how many floors does this thing have? 108 floors. Okay. 108 floors. So this one has 50, 55 floors more. That's crazy. Okay, so anyway, we're talking about the Burj Khalifa here. So Ryan is washing windows on a skyscraper. He lowers himself 6 times. So I'm going to highlight that. Lowers himself 6 times. So that'd be a -6. Going down an equal distance each time. That's key. Same distance every time. Okay. In all, Ryan lowers himself 48 feet. What integer represents the change in Ryan's position each time he lowers himself? So what I'm going to do is I'm going to say -6 times, he's going to do it -6 times. How far he goes determines the total distance of 48 feet. Okay. So we were given the 48 feet total, and we were given that he lowers himself 6 times. How far each time when it was the same distance every time? Well, we're going to divide by -6. So anything divided by itself is 1, and 1 times x is x. And a positive divided by a negative is negative. Oh, by the way, he lowered himself 48 feet. Let's just leave it 48. So this is going to become -8 feet per lowering. So he's going to lower himself 8 feet, lower himself 8 feet, do that 6 times. He has now decreased his elevation by 48 feet. What does this integer tell you? Well, it tells you how far he went each time he lowered himself. Okay. Now Ryan is washing windows. Okay, we just did that. Skip that page. What integer represents the change in Ryan's position each time he lowers himself? It was -8. How does that integer show that Ryan is going lower? It is the negative. Okay, he lowered himself -8, or do I have a negative back here? Where did it go? Yeah, -8. So the negative is what shows that he's going lower. Okay, down is negative, up is positive. Look ahead. One way to find the integer that represents Ryan's change in position each time he lowers himself is to divide. An integer can be divided by any integer except 0. Okay, let me read that again. This is really important. An integer can be divided by any integer except 0. So I cannot take 5 and divide it by 0. That equals undefined. Okay, we'll get more into that when we start talking about the slope of a line. But at this point right now, we can't, if we had 5 things and we divided it amongst 0 people, let's say, It can't be done. It makes no sense. Therefore, we call it undefined. Any rational number can be written as the quotient of two integers, where the divisor is not 0. That means every rational number can be written in the form of a divided by b, where a and b are integers. However, b cannot be 0. Okay, but a can be 0. So we can take 0 things and divide it amongst 5 people. Everybody's going to get nothing. Okay, 0 divided by 5 is 0, but 5 divided by 0 can't be done. One way to think of a rational number is as the fraction a over b. Okay, then it says to explain why it makes sense that a can equal 0, but b cannot. And I've already done that. Part B says, how can you write 0.07 in the form of a over b? Okay, so if we don't say 0.07, okay, these are ones. Let me change colors here. This is called the ones position, this one here. Then when you cross the decimal and go over here, this is tenths with a th. This is hundredths. With a THS. So this is 7/100ths. And to write that, you just say 7 over 100. That is 7/100ths. Okay, so that's how we write 0.07 in the form of a over b. Then it says, how can you write 1.07 in the form of a over b? Let's do this over here. 1.07. Well, if I put this 1 down as an integer, and 0.07 is 7/100ths. What's going on here? My pen's malfunctioning. Help. So 1.07, see, I got distracted. 1.07 is the 0.07 portion, or 7/100ths, is 1 and 7/100ths. Well, whenever we have an improper or mixed fraction and make it improper, which is what they're asking us to do here, you take the denominator times the whole number. 100 times 1 is 100. Add the numerator and get 107, and it's divided by the original denominator. So this is 1.07 written as a fraction a over b. It's improper, but it's in that form. Okay, part C says, when a rational number is negative, you can write it as a fraction in 3 different forms. For example, you can write -4 as -4 over 1. Let me highlight these. So -4 is an integer, but if I divide it by 1, it is now a rational. And it's -4 in the numerator, +1 in the denominator. Or I could put +4 in the numerator and -1 in the denominator. Or I can put 4 over 1 and throw a negative sign out in front. So it says write each as a quotient using the divisor or the division symbol. So the first one, so I'd say -4 equals -4 divided by 1. Okay, that's this one. The next one would be -4 equals, and now it's +4 divided by a -1. So the bottom was negative here. And this one here is -4 equals a -1, if you will, times 4 positive divided by 1 positive. So our order of operations says to do the parentheses first. So 4 divided by 1 is 4, and then multiply by -1 to get us this negative. Okay, and that is how these are all equivalent. So now we're going to close. Quick lesson. Why is -3/4 a rational number? Well, if I took this, that means -3 divided by 4. So let's just do the positive first. A negative divided by a positive is negative, so I'm just going to throw that up there. And 4 will not go into 3, so I'm going to put a 0, and I need a decimal. And then I need a 0 down here. And 7 times 4 is 28. And that becomes 2. 10 minus 8 is 2. I need another 0. Bring that down. And 4 will go into 25 times. So negative 3 divided by 4 is equivalent to negative 0.75. So if you have a decimal or a fraction, it is a rational number. I cannot write this as an integer, a whole number, positive or negative, if you will. So therefore, it is rational. It is not a repeating decimal, and therefore it's rational. That's the end of session 1. Hi there, Mr. Holcomb here with another lesson in pre-algebra. This is Unit 3, Lesson 12, Session 2. Multiplying negative rational numbers continued. Same learning targets. I'll skip those for now. And we'll start with this. Try it. Make sense of the problem. Mount Whitney Trail starts at an elevation of 8,350 feet above sea level and ends at an elevation of 14,500 feet above sea level. The temperature changes by negative 5.4 degrees for every 1,000 feet gained in elevation. What is the change in temperature from the starting elevation to the ending elevation of Mount Whitney Trail? So from the starting to the ending. So that's the first thing we need to do. We end at 14,500 feet above sea level. Wow, that's high. And we subtract 8,350 to see how long the trail is in elevation. So 10 minus 5 is 5, 4 minus 3 is 1, and 14 minus 8 is 6. So we're at 6,150 feet of elevation change from the beginning of the trail to the end of the trail. Okay? And that's that yellow trail up above John Muir Trail. Okay, so the important information is the starting point, the ending point, and the elevation difference between the two. So then every 1,000 feet, so what is the change in temperature? We now have to divide this by 1,000. Okay, so what I'm going to do is just go like this, divided by 1,000. What that does is move the decimal place 10th, 100th, 1,000th. That's going to be 6.15. Okay, that means that is how many thousands the trail is from start to end in elevation change. For every 1,000 feet, it changes by negative 5.4 feet. Okay, so there's a couple ways we can look at this. I'm going to stop at this point right here, and we're going to take a look. Okay, let's skip this and onto this. You can use a diagram to understand the relationship. So we started at 8,350 feet, and let me just go back, and that's right here. Let me highlight it with the same colors. So there's our starting point. Whoops, thought I clicked here. There's our starting point. And we ended up at 14,500. So if I go here, that is right here. So what happened? Well, we increased 1,000, increased 1,000. That is negative 5.4. Increase another 1,000. That's another 5.4 degrees drop. Increase another 1,000. That's another 5.4 degree drop. Increase 1,000, another 5.4 degree drop. You get the idea? Okay. And then last time right here, but then notice what's happening. Then we're only addressing the last 100 and last 50 feet separately. So this model here is going to show us all of the changes. So then I can model just this portion, the 1,000 foot change, and there is 6 of them, by doing negative 5.4 times 6. It's 24. 6 times 5 is 30 plus 2, 1 decimal place. So it dropped 32 degrees, 0.4 actually, negative 32.4 degrees from this point to this point. Okay, it's getting quite cold. But then 100 feet is 1/10 of 1,000. So 1/10 of 5.4 is 0.54. Okay, see what they did there? Multiplying or dividing by 10. So then we have to add another negative 0.54 degrees. Okay, so that's going to be a 4 because there's going to be a 0 here. 5 plus 4 is 9. 2 plus 0 is 2. And then bring down the 3. So now we're down 32.94 degrees. Okay, but half of 100 is 50. That's what they did here. They divided by 2. Divide 0.54 by 2 and you get 0.27. So I'm going to add another negative 0.27 for that last 50 feet. And 4 plus 7 is 11, carry the 1, 9, 10, 12, carry the 1, 2 plus 1 is 3, and we are now at the total. It will have dropped 33.21 degrees in the difference in the time you leave the beginning of the trail until you get to the end of the trail. The temperature dropped 33.21 degrees. Okay, dress accordingly. Another way we could do it is you can multiply to find the change in temperature. So we got 6,150 feet by subtracting the starting point and the end point, or the end point from the starting point, or actually it's the end point, the starting point from the end point. And then it's decreasing 5.4 degrees Fahrenheit every 1,000 feet. That's at a rate of negative 5.4 per 1,000. Change in temperature equals rate of temperature change times change in elevation. So negative 5.4 over 1,000 times 6,150, okay, is going to be the same as negative 5.4 times 6.15, okay, which I think I had back here. So here's our 6.15. So then we'd multiply it by a negative 5.4. So this is multiplication, okay? All right, so when we do that, we're going to get the same answer. And I could check it with my calculator. Okay, so negative 5.4, okay, times 6.15. Is negative 33.21. And that's what we got here. Beautiful. All right, next problem. A peregrine falcon. I'm not sure if I'm pronouncing that right, and I want to. Yeah, I just looked it up online. Peregrine. A peregrine falcon is a bird of prey, meaning it hunts and feeds on animals larger than itself. Okay, so go big or go home. Falcons have keen eyesight for spotting their victims from over a half a mile in the air. And when diving, they may reach a speed of 200 miles per hour. Wow. What are some examples of birds you have seen near where you live? Well, let's see. Where I live, I see great blue herons and egrets the most. Some osprey, but not lately. I think they might migrate. And bald eagles. However, this weekend I saw 2 loons on the lake. All right. So let's take a look at this question. A peregrine falcon dives for prey. Its elevation changes by an average of 11.5 meters to the negative per second. So it drops 11.5 meters per second. The dive lasts for 3.2 seconds. What rational number represents the change in the falcon's elevation? Okay, so we have 11.5 meters per second, and there's 3.2 seconds this thing's going into a dive. So the 11.5 meters means a decrease of 11.5, dropping 11.5 meters every second. And it's going to do this for 3.2 seconds. Okay. So what represents change in its elevation? Well, we're going to take negative 11.5 and multiply it by 3.2. Okay. So I would write it like this if I were going to just plug it into a calculator, but I'm not. So I'd do it like this: 11.5 times 3.2. And I'm going to worry about the sign after. 5 times 2 is 10, carry the 1. 2 times 1 is 2, plus 1 is 3. 2 times 1 is 2, bring down a 0. 3 times 5 is 15, carry the 1. 3 times 1 is 3, plus 1 is 4. 3 times 1 is 3. Add 2 decimal places. And it's negative, because a negative times a positive is negative. So what does this number mean? It means in 3.2 seconds, this falcon dove 36.8 meters. Okay, in 3.2 seconds. That's pretty fast. And now let's apply it. Find negative 1/9 times negative 27. So I'm going to leave negative 1/9, a fraction, because we have a rule that if you divide by 9, your answer, so negative 1 divided by 9 is going to be a negative, right? Negative divided by positive is negative. And whenever we divide by 9, we're going to get a repeating decimal of that number. So negative 1 divided by 9 is negative 0.1 repeating, or 0.1111111 forever and ever. So since we're multiplying, we don't want to be here forever, so don't make it a decimal. Leave it a fraction. And instead, let's make negative 27 a fraction. Okay? So a negative times a negative is positive, and 1 times 27 is 27. 9 times 1 is 9. 27 divided by 9 is 3. So there's our answer. Another way I could do it is negative 1 times 9, or divided by 9, times negative 27 over 1. And then what we do here is, well, a 9 will cancel or reduce to 1, and 9 will go into 27 3 times. And then we get negative 1 times 3, which is negative 3. And we get 1 times 1, which is 1. Okay. Whoops, I'm sorry, it's positive. Negative 1 times a negative 3 is positive 3. My fault. And we get 3 over 1, which is 3. Either way you do it. Okay, so now here's a closing ticket. A freezer in a lab is set so that the temperature changes at a rate of negative 1.6 degrees Celsius every hour. What is the change in temperature after 4¼ hours? There are 2 ways we can do this. Negative 1.6 times 4¼ or, so I'm going to write it again, negative 1 times 6, or 0.6, I mean, times 4¼ So I'm going to just write it 2 times. 2 ways to do this. Okay, I can make negative 1.6 a fraction, which would be negative 1 6/10. And then I'd multiply that by 4¼ But in order to do that, I need to make these improper. So it's going to be a negative 2 times, or 10 times 1 is 10, plus 6 is 16 over 10. And then 4 times 4 is 16, plus 1 is 17 over 4. Okay. To make these numbers smaller, I'm going to reduce first. That can be a 1 and make 16 a 4. 16 divided by 4 is 4. And then I get 7 times 4 is 28, carry the 2. 4 times 1 is 4, plus 2 is 6 over 10. And a negative times a positive is negative. Well, 68 divided by 10 is, let me not go into my other, it's going to be negative 6 and 8/10, but that reduces to negative 6 and 4/5, I believe, will be my final answer. However, making them a fraction's one way. How about we make this a decimal? So I'm going to leave that negative 1.6, and I'm going to convert 4 1/4 into a decimal. Okay, so let me get rid of this. So 4 times 4 is 16, plus 1 over 4. That's how we do it. 17 over 4 is the same as 4 1/4. Okay. Whoops, I don't want to make it a mixed fraction. My fault. Apologize. I already did that. What I want to do is make this a decimal. So negative 1.6 and 4 1/4 as a decimal is 4 1/4 is 0.25. Okay. So in order to multiply these, we would then do this. Okay. And to do that, we take 4.25 times 1.6. 6 times 5 is 30, carry the 3. 6 times 2 is 12, and 3 is 15, carry the 1. 6 times 4 is 24, plus 1 is 25. Bring a 0 down. 1 times 5 is 5, 1 times 2 is 2, 1 times 4 is 4. Add, and get 8, and get 6, and we have 1, 2, 3 decimal places. I get 6.8. Well, 6.8 is 6 8/10. Oh, by the way, negative times a positive is negative. So I get negative 6.8 if I turn it into a decimal, and that is the same as negative 6 8/10, or 6 4/5. Okay, that brings us to the end of session 2. Thanks for watching, and have a great day.